On example 5, we have this quadratic, but notice I got a y squared and a y, so I need to factor it. But in order to factor it, it's got to equal to 0. That's the key. You can't use the zero product property unless it equals to 0. So what I'm going to do is I'm going to subtract 45 from both sides. So my new equation is 25y squared minus 60y, and then 81 minus 45 is 36. Oh, this might have been a perfect square, but I didn't notice it, but that's okay. But now, let's see if I can factor this. I'm wondering if it's a perfect square because 25y squared is a perfect square, and 36 is a perfect square. Let's see if that works out. Half of negative 60 would be negative 30y. Let's see if I get my factors. Well, 25y squared and 30y would be 5y. And then negative 30 and 36 would be negative 30y, and 36 would be negative 6. And then if I go across, I'll get 5y. And I'll get oh, it is a perfect square. So I can say 5y minus 6 squared equals 0. I can use my square root property here. And the nice thing about 0, there is no plus or minus 0. It's just 0. So I get 5y minus 6. We'll add 6 to both sides. When you solve it by factoring, we want fraction answers. So we divide by 5. So y equals 6/5. This is a double root. You can graph that and see if it actually just touches once at 6/5, and indeed it does. Okay, now, how about writing a quadratic equation given the graph, but I don't know the equation? So here's what we're going to do. We're going to find the factors of my related expression. You're going to determine whether A is positive or negative. Is it a happy or is it a sad parabola? And you're going to use another point to find the value of A. So my formula is going to be this. Y equals A times x minus one of my roots. I'll call that R1. Times x minus my other root, R2. My roots, remember, are my solutions or my x-intercepts. So on this one, root 1 is going to be negative 2. Right here. Root 2 is going to be 6. I get those from the graph. So I can write my equation, y equals A times x minus a negative 2. I'll go straight to x plus 2. And then x minus 6. Now, I'm going to pick a point that is not one of my roots. You can't pick negative 2 or 6, but I could pick any point I want. And let's do my vertex. I like the vertex. I could pick the y-intercept also. Maybe you want to do the y-intercept. I changed my mind. Let's do the y-intercept. My y-intercept has the point 0, negative 6. In other words, x is 0, y is negative 6. I'm going to use this to solve for A. And I like 0 because nice things happen with 0. So y is negative 6. I'm going to solve for A. X is 0, so I'll say 0 plus 2 and 0 minus 6. So I'll get negative 6 equals a times 2 times negative 6. Well, that's negative 6 equals negative 12a. Divide both sides by negative 12. A is 1/2. So now I can write my equation. Y equals A, which is 1/2. I know I'm doing it right because A is positive, isn't it? And then I'll say x plus 2 and x minus 6. Now we could check that. Let's actually check that. So I'll type in here. Let's get a new graph here. Y equals 1/2. Get out of the denominator. And we said x plus 2. Typed in 0, I meant x. And then x minus 6. And there's my graph. I don't know what happened to my screen there, but that's exactly what we have, isn't it? So we're doing it right.